So one quick trick you can use when trying to translate a piecewise functions graph into actual piecewise notation is you can think about like what type of function you should, what type of like algebraic equation or expression you should be seeing based on the sketch. So if it looks something like this, or if it looks something like this, making that parabolic shape, it's probably going to be something with x squared. So this over here is starting to make the parabolic shape, starts leveling off, but it's still got that curve that makes us think that this could easily be a quadratic function over here, right? And so then once you've identified whether it's going to be like an x squared thing or whether it's like a straight line, this is like y equals mx plus b, so you're expecting to see like maybe x plus 1 or something like that. So once you've identified the type, then you can start focusing on the x-axis. You want to think about the values for x that this function exists on. So this curve exists, and looks like the arrow, it looks like it keeps going. They don't put an arrow on these graphs, but it's implied that it keeps going. So from all the way back here, there's probably some value for x that if we've traced it all the way up, it would hit this curve. It just goes from negative infinity up to 0 and it stops. So when I make my selection, I'm thinking that my x squared type of graph needs to stop at x equals 0. So this one I'm going to rule out right away because when we hit 0, look, it's got an open circle, right? I think it's an open circle, yeah. It's an open circle, but this is implying a closed circle. That makes me think that's one we need to skip. This one looks like it's going to be my winner because there's x is less than 0. So my x squared function is happening when x is less than 0 over this way. And then let's just check the rest to be sure. X plus 1, this is like y equals x plus 1. If we go up here, this line right here starts at 1 on the y-axis. That's the y-intercept. And has a slope of 1. So it goes up 1 to the right one, up 1 to the right one, up 1 to the right one. So that's working. This line is only supposed to be between 0 and 4 on the x-axis. And it's between 0 and 4, so that's working out so far. And then it says y equals negative 2 when x is greater than 4. So here's where x is 4. These are all the x values where x is greater than 4. And it is spitting out y equals negative 2 again and again and again. So that is the correct selection down there. Looks like they're all pretty similar, huh? Maybe like it looks like one differs like with a y-intercept. But the other thing you can do is you could sketch, like you could go through all 4 options and try to sketch each option. That would just take a long time because you'd have to do 4 different sketches. But like if I graph this one down here, for x is less than 0, then I've got the graph of x cubed minus 2. So it's when I plug in x equals 0, I should get out negative 2 for a dot. And then if you study the x cubed function, if you go to Desmos and type in x cubed, you'll see it makes a wavy line like this. However, this is only defined when x is less than 0, so my wavy line needs to stop once I hit x equals 0 right here. So that's definitely not our graph up here. So it's easier to look at the graph and then try to match it up rather than take each 4 of these and graph them. But I encourage you, if you have trouble with these, to look at them as 3 separate equations. Like this top one is saying y, easier if I type it out. This top one is saying y equals, oops, got a weird font going on. This top one is saying y equals x squared minus 2. Right, and that only happens when x is less than or equal to 0. And then the middle one is saying y equals x, between 0 and 4 on the x-axis. And then the last one down there says y equals 2 when x is greater than 4.